Okay, so we've heard now from somebody who teaches how to speak, somebody who teaches how to write, and now we're going to hear from somebody who's been involved in teaching how to code. So while Shen, of course, is sort of teaching people how to code, the class is not specifically focused on coding. And so Daniel, over the last semester, has taught a Capstone software engineering class where he asked people to use LLMs in software design, so in the actual practice of their course projects. And he's going to reflect a little bit, I think, on how that went. So thank you very much, Daniel.
If I can connect.
If he can connect, yes. Looks like we're getting there, maybe. There we go.
Okay.
All right.
Thank you so much. It's so much fun to be here. And thank you to Sam and to Eric for creating this lovely workshop. I've been enjoying the talk so much so far, and it's obviously so many provocative questions to think about. So I'm going to tell you about the experience that we had in a particular class. Here are my co-conspirators. We had a fantastic team of teaching assistants, and I'd like in particular to point to my co-lecturer, Mitchell Gordon, who's much more of an expert on AI than I am, and my PhD student, Egan Meng, who was extremely involved in both planning this class and in executing it and building tools for it. The other TAs were also remarkably helpful and tolerant of a very experimental class. So let me tell you a bit about the class, first of all. So here's the blurb that we put up on the website. Basically, we claimed you can go beyond coding, design and build cool apps. We've, for many years, been using an approach to software development called concept design. The new thing was how to use LLMs in design and code. And of course, we warned them, you're up for a rough ride. This is going to be a bit experimental. I want to tell you a little bit about the sort of design framework of the class to give you a sense of sort of where we're coming from. And it's inspired very much by a point of view on design, which was actually articulated a long time ago by Mitch Kapor, the famous entrepreneur, in a speech that he gave to a CEO forum of tech companies back in 1996. And he asked the following provocative question. He said, when you go to design a house, you talk to an architect, not an engineer. Right? So he said, so why is that? And the answer is because the criteria for what makes a good building fall outside the domain of engineering. Now, this, of course, is very hard for us at MIT to hear. Right? The engineers might not be there from day one, but the point is, of course, you need the engineers to prevent the building from falling down. But it's no good having a building that doesn't fall down if it doesn't have space and light and so on that people actually need. And so he said, similarly in computer programs, you need to focus on the selection of what he called the various components driven by conditions of use. And then he said, how is this to be done? His answer was by software designers. So in a sense, we are trying to, in this class, to train software designers, to give this point of view, the interface between the technology and the world. It's interesting, by the way, that as far as I know, there still aren't any people called software designers out there. There are people called product managers, software architects, user experience architects, lots of people who do software design, but we don't yet have software designers. That's a topic for another day. In thinking about where design, in particular concept design that we teach, sits in terms of how I understand software and how I teach it to the students, I think of software, the design of software at multiple different levels. There's a physical level, which is basically making the software so that it works with human physical capabilities, sight, and those kinds of things. Linguistic, how we actually talk to the software, and that includes not just words, but also symbols. I love this. I always show this symbol because it highlights some of the perils of linguistic communication. This is obviously a sign that tells you roadworks ahead, but it's affectionately in England called man having trouble opening umbrella. And so that's sort of an important insight for someone trying to design software. And then at the top level, the conceptual level, which is really what the semantics of the system is and what it's all about. And so there are basically a bunch of different skills that we've taught over the years at these different levels. And if you're familiar with the field of human-computer interaction, you'll recognize many of these things. Now, the course is I'm trying not to say obscene words at the point, but it's insane how much stuff is in this class. And every time I teach it, there's, I ask myself, surely there is some way of reducing stuff. And the problem is we're trying to teach students how to design apps, but also how to build them. And so they need all the technology that they haven't learned in other classes in order to build them. And so we have this massive pile-up of technologies on the right that we have to learn, that they have to learn. And we've been trying to knock some parts of it out. We'd like to knock more of it out. We managed to get rid of JavaScript, for example. They don't need to learn the programming language because wonderfully that's now taught in the precursor class, and that wasn't true until a couple of years ago. We teach them a whole bunch of ideas. In green here, by the way, are the things that were new this term, ideas that we emphasize. And you can see the LLM-based things. The red things are things that we took away. So you'll see, for example, this term, we stopped talking about usability, heuristics, on the grounds that the design of user interfaces is essentially a solved problem. I'm not entirely sure that's true, but I think it's true to some degree. The activities are basically, what the students do in the class, and we've also sort of tried to, in order to keep the class under control, cut back on some of those things. And I must say, I regret some of the things we've pulled back on. We had the students do a sort of design portfolio and write a blog about, what they heard in lecture and how they connected it up to problems in the world. And the truth is, it was an absolutely mammoth job reading and grading those. And so partly we cut it out because we didn't have the capacity to do it. I think that might come back in again. I want to tell you a tiny little bit about concept design. In short, this is a shameless plug for my book about concept design. In short, the basic idea is to break software down into components, each component motivated by some purpose and separating out the behavior associated with that purpose. And this gives you a rather different emphasis when you do software design than if you don't use concept design. In particular, it gives you a tendency to think about familiar patterns, to align the code with the behavior more than is usually done, a much more radical separation of concerns and elimination of dependencies. So just to give you one sort of picture that gives a little bit of a flavor of the difference, this is what a traditional application structure that students would build, in a web application building course would look like. So this would be like a little social media app. And typically the way it's done is that you build sort of stacks in the app that correspond to different kinds of objects. So you might have a user stack that manages users, an article stack that manages articles, a comment stack that manages comments, and so on. And this way of working actually tends to lead to an enormous amount of conflation and fragmentation. And the reason, in short, is that breaking things down according to the agents, the people who do it, is actually not a very good way to do it. Because if you think about it, users do many different kinds of things, and they play many roles. And if you conflate all those things, you end up in a mess. And that's why you get all the dependencies. In a concept design, you do something much simpler, which is you identify the activities. So you might say that users authenticate themselves. They have names. They display their properties to other people, like their bios and their avatars and so on. And we track karma, which is again about users, but it's a very different thing, trying to determine who the well-behaved users are. There's posting, there's commenting, there's upvoting. And these can all be described completely independently. And notice there are no edges between them. There are no cross-dependencies at all. They are defined completely independently of one another, and they are composed into a system by what we call synchronizations, which essentially will say things like, maybe when a user gets an upvote on their post, they get a karma point. So that would basically connect the upvoting, the posting, and the karma by basically synchronizing those actions. And if you think a little bit about programming, you'll see immediately that this is extremely well suited to LLM-based coding, because it means that you can basically let the LLM loose on the description of each of these services, if you like, completely independently. And you don't have to put the LLM in a system like the one on the left, where they need to understand the interconnections. So that's basically by way of background. So what do we actually do? Well, we've been thinking about AI in the class for a while. This actually goes back to some experiments that my wonderful PhD student, Jeffrey Litt, did back in 2022, 23. And what he did was he was experimenting with building basically tutors for the class. And he built a thing he called Concept Tutor that basically asked students questions and then had them basically come up with tentative solutions. And then basically gave them a commentary on it and had a chat window to help them understand what they were doing. Sadly, we never actually deployed this. It was never polished enough or successful enough to actually use it. In preparing, but then it basically became clear to me that it was time to embrace LLMs. And because the class is a Capstone senior level class, it seemed we had no excuse for not teaching our students how to use LLMs in software development. We couldn't go on saying what we'd said the previous year, which was, sure, you can use LLMs, just keep it to yourself, We didn't quite say that, of course, but that was essentially the message. So what did we actually do? Well, Mitchell and I basically met every week in the spring, arguing and thinking about the class and what we were going to do. I don't think I've ever spent so much time preparing for a class. We then put out a glitzy promotional poster in May that got us a lot of flack on Reddit because it had a horrible typo in it. And it was indeed, generated partly by Gen AI, and people thought it was horrible and disgusting and represented everything appalling about those awful MIT professors, who have basically given in to the AI hype. So that was kind of funny. And then in August, because partly because we had a great opportunity and partly because I was terrified about trying this massive experiment on a big class in the fall, we did a dry run of the idea of how we were going to generate code in this wonderful thing run by a bunch of students in CSEL called the Sunday Club. And they've basically been vibe coding for, I think, they've done it like 70 or 80 Sundays in a row. It's quite incredible. So we went and spent a Sunday with them and taught them our approach and sort of made sure it wasn't a disaster. What did we actually do in the class? Well, the most important thing, we encouraged LLM use everywhere. From design through to implementation, testing, the lot. You might want to know what LLM they use. That actually turned out to be something we were very concerned about, because what we discovered with the Sunday Club experiment was that if you just asked Cursor, for example, to do concept design, it didn't understand that concept design was modular. It still looked at your entire code base. And the problem with that was Cursor charges by the token, right? And if every single query involves looking at the entire code base, it's extremely expensive. So compared to the work my grad student Egon had done using our tailored version of concept design, which had cost about $10 for like several months worth of activity, he spent about $100 in one night playing with Cursor. And so we realized this was going to be a big problem for the students if we weren't very careful. So we were pretty worried about that. We got Google credits of $50 per student to use Gemini. It turned out Cursor was supposed to be free. They advertised that students can sign up. Turns out they can't. The registration doesn't work. And we don't know if that's just because they vibe coded their registration software, or if it's because this is actually, they make a claim that they're not really delivering on. Many of the students used other LLM-based tools like Copilot. We built, or my student Egon built a tool that I'll tell you a little bit about in a minute, which essentially wraps the Gemini LLM. And the idea is to make a very focused and intentional way of working with designs and code in which the student explicitly, the user explicitly identifies the context of the query that they offer. Unlike in Cursor, for example, where it's basically complete free-for-all. And also snapshots all the queries and results. So you have basically a full log of everything that happened. And we decided we would also, this was partly because Mitchell convinced me this was important, we would also let them use a so-called vibe coding tool. We would let them use Cursor, even though I had some misgivings about that. I think Mitchell thought correctly that we should expose them to the state of the art, as it were. But as you'll see, there were some disasters that produced, as well as, I think, some good learning experiences. So just to show you what it looked like, this is this is Egon's tool opened in a markdown browser called Obsidian. And basically, there's a collection of background documents. We wrote a lot of background documents for the students that they could basically enter into their prompts. They would then create a prompt as a separate file, and then each file behaves like a thread, like in ChatGPT, a separate chat. So you can add things to the end. For example, you can ask questions about what it's generated. And then it would, for example, the students would use it not only to implement concept specifications, but also to generate specifications. For a lot of the code they were writing, if you wanted user authentication, for example, nobody, has to figure out user authentication. You just say to the LLM, make me a user authentication concept, and it generates one. Then you say, implement it for me. It implements it. Then you say, test it for me. It tests it, and you're done. But of course, there are more interesting concepts that can't be handled like that. Now, here was the crucial bit. You'll see at the top there are these links. And what that says is that at the top of this file, the LLM should only base its response on the particular prompt, which in this case is actually just the one line. It says, generate code for the Likert survey concept. That's the entire prompt. But it depends on probably, 10,000 words of background explaining the whole approach in those documents. And then, as I said, we snapshot everything. This, in contrast, is what Cursor looks like. I actually took this screenshot a night or two ago from a video from Cursor's own website explaining it. And you can see they've just asked Cursor to add some confetti or something. And it says, sure, I'll help you do that. And it goes basically, you ask the question, it does everything for you. And it not only reads all your code, it will write all over your code, it will install things for you, it will execute things for you, it will download and install malware for you, anything you want it to do, it will do. And I thought it was kind of cute that in this case it actually installed a particular piece of software, and the person doing this tutorial for Cursor itself said, sure, I didn't even know that existed. and that's sort of, that's sort of interesting, right? That can be good, that can be bad. So what actually happened? Well, let me tell you the good things first. The students did fantastic projects. Here's an example of one project. I love this one because we were encouraging, the students got to do whatever project they wanted for their personal project and their team project. This is a student, Calvin Farrow, whose parents are farmers in Iowa, I believe, and they have an app for tracking the health of their herd. And he thought that app wasn't very good, so he built a new app for them. And it's an LLM-powered app as well. So basically, it collects statistics about all your cows and sheep and so on, and then it analyzes them and tells you, how a particular cohort is doing. Here's a team project, and this, I think, this sort of demonstrates how far you can go with LLMs. This is a team who basically built a tool for discussing papers. It's kind of like a kind of archive-like tool where you can upload papers in PDFs, but then you can have discussions about them. It's the kind of thing that's been done before. David Karger has a tool called MB, which is a bit like this. But what was impressive was that they built this in just like 4 weeks. And they got like the highlighting to work in the middle of the PDF document. If you've ever played with PDF, you'll know that's not easy to do. So very impressive. So what did students use LLMs for? In short, everything. I'll point out in this list probably the more interesting things, maybe not interesting intellectually, but not that surprising, is they used it to check that what they were handing in matched what was in the assignment request. We encouraged them to use the background documents we gave them as kind of rubrics to check the quality of their work. And they didn't do that as much as we might have hoped, but they did to some extent. I want to tell you a little bit about some comments that they made. So we surveyed them after every assignment, so that's basically every week, and we asked them what they used LLMs for, and some other questions about the class. So here's a typical comment. I liked it. I thought it was fun. Amazing to see how much AI really helps with coding. That's one comment. Here's another. I sometimes feel like the over-encouragement on LLMs makes the assignments less fun. And then he says he likes coding, and he used to code in previous courses. He said, but now I'm not doing it. And he said, but I couldn't have got the assignment done without LLMs because it was so demanding. And then he says, this is really sad, it feels frankly like a brainless activity, takes away from the fun of development. I fear for the future of software engineering, my place in it, time to be a plumber, I guess. So I actually take this seriously, especially because plumbers are so well paid nowadays. On the team project, we had a particular requirement for writing reflections. I want to show you two of those. Here's one. This was very thoughtful. This is basically someone saying that the context tool worked. They were able to build things in a nice incremental way, modular and predictable. And then they said, when they started using Claude Code, which is one of these agentic things, they said it was not good. The model modified files I didn't intend to change. It led to merge conflicts. This basically means they couldn't work as a team because it was writing all over the place. And so if you were working on one part of it, it was interfering what other people were doing. And then they said, basically, using the ideas they learned how to basically control this and to make it nevertheless work. So that was kind of exciting. I want to show you two reflections on the personal projects, which I thought were interesting, and you'll see why. And one of them, we asked them to reflect on their sort of general experience, and we said, what mistakes did you make? And so I thought this was really good. This was a student who was actually extremely successful and did fantastic work and got an A+ in the class. And he said, my biggest mistake was basically taking on too much. He actually was building an app which you might think was mundane, but it turned out to be super interesting. He was in a living group where they basically cooked meals for everyone in the group. And what they needed to do was take their recipes and turn them into shopping lists. So basically, someone proposes a recipe, you count the number of people, you multiply the recipe ingredients by that number of people, you find out what you got in the storeroom, you figure out how many items you need, you figure out where you need to get them from, you put in an Instacart order. And apparently, people in the living group spend about 10 or 20 hours a week just doing that ordering process. And so he thought he'd automate it. And he built a great app. I don't know how close it was to solving the problem, but he did a really great job. But as he says, it took him a huge amount of time. And he said, I've learned that biting more than you can chew sometimes can be a lot worse. In the future, I'll focus on being honest with how long things take. So this is a good lesson, right? Look at this one in contrast. This is in response to the question, what challenges did you face? Implementation complexity, integrating pieces, wiring APIs, and edge case handling were time-consuming. Context fragmentation, comprehension updates slow, debugging multi-file flows. So if you haven't seen a lot of this kind of stuff, you might not recognize this immediately, but this goes by the name of AI slop. This is basically garbage, completely generic, could have been written about any project. It's essentially completely content-free. And this was a disappointing thing, that even in the reflections, there were a non-trivial number of students who turned to the LLM to basically reflect for them. So good outcomes. What was good? They built some great projects. The concepts and the LLM-based process definitely helped them do teamwork. And we survived. We were worried that they were going to run out of LLM credits and we were going to have a huge communist uprising. That didn't happen. The bad outcomes, I think, were undoubtedly some reduction in the mastery that the students had of the frameworks in particular. Many of them experienced loss of control. And in particular, we did an analysis because a lot of students were telling us that our framework that we gave them didn't work. And it turned out the reason it didn't work was because Cursor had broken it. That when they asked Cursor to add application-level code, it basically broke the library. And not only did it break the library, but 80% of the students let it do that and didn't notice that, and handed in code with the library broken. And we vibe coded a little script to detect examples of that. That's how we know it was 80% of them. And as I said, LLM slop, students being discouraged, wanting to become plumbers, and reduced engagement with staff. That was actually kind of notable. Like many fewer students coming to office hours, many fewer students interacting on Piazza. I want to close just by saying something about a little analysis we did. So we basically decided that we should try and do something a little bit more objective and statistical. So we had a little workshop of the TAs a few weeks ago, and we basically had the TAs assign each student, rate each student's work on, first of all, their skills, general skills like communications ability, reflective practice, their skills with the concept design framework, their skills using LLMs, and so on. Then the outcomes. How good was their code? Was it clear? How good was the usability of their product, and so on? And we also extracted stuff from student surveys. We'd ask them how much they enjoyed it, how often they went to lectures, that kind of stuff. And here's a sort of bewildering picture. And basically, this is a kind of heat map that for any pair of these outcomes and skills will tell you how they're related. So in short, the big, and it's sort of organized so that the red things in the middle are the ones that are have the strongest correlations. The double star means very statistically significant. The single star means statistically significant. And I don't have time, because I'm sure you want me to stop, to explain really a lot of what's going on here, but I want to point out two things, basically. The first is that there are a cluster of skills and outcomes that seem to be very strongly correlated. They are your communication skills, your ability to have basically reflective practice, your concept design skills, your code quality, the quality of your product, your LLM aptitude, and your final grade. Now, it's possible, and I should say, my humanities colleagues will be delighted to hear this, the completely dominating feature here, or the one that comes out atop of all of them, is communication ability. Now, it's possible that if you're a better communicator, you just get better grades because you sound smarter and you're able to persuade the TAs to give you better grades. I'm not sure that's true. But I think there's actually a real effect here, which is that the students who are better communicators are also the ones who come up with better concepts and write better code and therefore produce better products and get better grades. The interesting thing, but I believe this is sort of standard in the literature, is that there's almost no correlation with any of these with enjoyment or difficulty or time spent. So if you spent more time or you enjoyed it more, didn't affect how well you did or what the quality of the outcome was. One interesting thing, if you look at it, is that LLM usage did increase the amount of time spent. So the more you used LLMs, the more time you spent. So in conclusion, here's what I would say. LLMs are advancing fast, and we can't ignore them. LLMs can enable our students to produce much more ambitious artifacts, and that's exciting in a design class. And also potentially, and I don't think they did this enough, engage more broadly and deeply with their work. But they can also be crutches, limiting their creativity, damaging learning, and seriously burdening the graders who have to read all this LLM slop. What will actually make the difference? So here's my personal take. My personal take is that what will make the difference if we actually hope that they will use LLMs to engage more deeply and more broadly and use them successfully is basically whether or not they have the personal agency, the curiosity, and the reflective practice to do it. And in short, I'm not sure that our culture at MIT encourages that. I think, in fact, our current culture encourages the opposite of all those things. And I think, so my takeaway from all this is that if we want LLMs to be successful, these are the things we need to focus on. Finally, just want to say I've had a bunch of other ideas about this that in a paper that paper makes it sound too grandiose, in an opinion piece that I've written, and would love people's reactions to that. And I put it at the tiny URL, not calculators. So with that, I'd be very happy to hear any questions.
It strikes me that you're sort of on the previous slide, that last piece of advice that you, or last comment that you have there, what will make the difference is about personal agency and curiosity is actually the same conclusion that Michael came to about writing, which is that, you know, what we have to do is to convince our students that to care. Like, we have to make them like want to do this. And, you know, that maybe the hard thing as educators about LLMs is that it lets the lazy students be lazy and still succeed. And I'm just, you know, I think I'm not sure if this is a question, but to me, it's very striking that both coding and writing have this, you know, I think same fundamental challenge when it comes to LLMs.
I think you're exactly right. And in fact, Sanjay Sarma and a colleague of his wrote a white paper in which they came to the same conclusion, that effective use of LLMs will rely on basically active learning and, what do they call it, and reflective practice. And I've also noticed that Per, who gave a talk earlier today, in one of his talks, which I watched online, talked about Lev Vysotsky. Did I get his name right? Who was one of the early, and sort of one of the things that Sanjay has also been pushing is the realization that a lot of pedagogical practices that were being promoted in the last century, which we have not widely adopted, I think are becoming ever more critical, like active learning and the role of reflective practice.
Yes, hi. My name is Eric Grunwald, I direct the English language studies, so we work with second language students. And I appreciate your last comment there about the culture. And I want to reference the comment that was just made, and the teacher earlier stressed the importance of not vilifying students, but the last commenter mentioned the lazy students. And I think it's more complex than that. Even Eric, in his opening remarks, talked about when crunch time comes, you're at the end of the semester, and and I see this with second language students, for whom a study showed still takes international grad students 50% longer to read a journal article, 50% longer to write one. The structural stresses of the workload and whatnot seem to inherently going to, if that's a sentence, push students to not be as agentic, curious, self-motivated, and I'm wondering if you see that yourself and would comment on that, what you mean by the culture there, and are there structural elements that are readily identifiable to give students the space to use these tools more helpfully?
I think that's exactly right, and it's my impression, many of my colleagues report the same thing. It's been getting much worse over the last few years, and our students are not lazy. Our students are very smart, and our students work really hard. They are really, really driven, and that's part of the problem. The problem is they're really driven to produce certain things, and we've brought them up in a world in which they think that the product of their education is the assignment, maybe the final quiz, the final project, it's the GPA, it's the transcript. And it never occurs to them that they are the product, that the product is actually improving their own brains and their own understanding of the world. And until we can convince them of that, one student said to me, I had a little sort of donut break, with some students, and asked a student, so why do you think a lot of students skip lecture? And they said, oh, well, I would never go to lecture if I had an assignment due. Why would you do that? If you've got the assignment due, that's what you're being graded on. It's as simple as that. And so I think basically our students have developed a value system that's sort of forced on them by the pressure that they're under. Jay?
So I was going to ask you about, you probably said something about how students work together on these projects. And I guess in the class I teach, I see students seem more motivated and more interested when they're working with a partner. Did you see that effect? Did you see LLMs actually isolating students more? That is, when they work together on a project, they worked separately because of the LLMs? What did that do to teamwork?
That's a fantastic question. I don't think I can really answer that. I'll tell you a couple of things I did notice, though. One is that the LLMs undoubtedly isolate students. They undoubtedly work more by themselves rather than interacting on Piazza, rather than talking to the staff. Just one random thing. I always tell the students in lecture, I want to talk to you about your work. I'm here. I'll help you with your project. Come talk to me. One student came to talk to me. One. That's not fair. One came to talk to me about pedagogy because he liked my lectures. One came to talk to me about his project out of 80 students.
That's been that way for 40 years.
Yeah, I suppose so. The second thing I'll say is that a really curious thing we noticed, we put a lot more emphasis on sort of product design and trying to find authentic problems. And we were curious to see whether it would impact the quality of their projects, whether they'd do more interesting things. And what we noticed was the personal projects that they did individually were much more interesting than the team projects. And the TA's explanation, I don't know if it's true, is the TA's explanation is there's a kind of lowest common denominator effect, that when they get together in a team, they can no longer do creative things because they all bring each other down. They all say, oh, that's too wild, that's too crazy, let's do something, let's get this done. And so, to be honest, I'd never heard of that phenomenon before, and I'm concerned about it and wondering. And I should say, of course, I don't want to end on a negative note about the students, because the students are fantastic. So I'll end on a negative note about myself instead, which is to say that I think there are all these problems there, and I'm not at all convinced that all the problems are inherent or are just basically failures of pedagogy of my own and the course. And so I think there are great opportunities to fix these things and do a lot better. I'm not sure how to do that and would love to hear people's ideas about how to do it. But I do think that I at least have these problems, and that many of these problems have been seen by my colleagues in other places. But at the same time, I think this is tremendously exciting. It's a very exciting time. So I want to end on that positive note. And I think that I at least find LLMs incredibly empowering. I use them, for example, to read technical papers where I have a back and forth with the LLM, having it generate new examples and pushing back on my reading of the paper and so on. So I think that if we could teach our students to make very creative uses of LLMs, I think it could be a real game changer. And so I'm very excited. And that's why I'm doing this. So I do think it's possible. So I don't want to end on a sour note. Thank you.